Hi, in this video we'll be talking about generators. A generator is a function that yields a sequence of values using the yield statement. When we call a generator function, a generator object is returned. The execution of the generator function is interrupted when a yield statement is reached. Then the value following the yield statement is returned. The generator function is not executed until the next method is called again on the generator object. When this happens, the generator function resumes execution at the point where it left off, and in the state in which it was when interrupted after the last yield statement. So all local variables are saved between calls. The execution is continued until it reaches the next yield statement, which again returns the yielded value. The way generator functions execute is very characteristic of them. Regular functions always start execution from the beginning, no matter where they left off in the previous call. Generator functions resume execution at the point where they left off. To better visualize the difference between a regular function and a generator, let's create a simple function and a simple generator that looks similar. Then we'll see how different they are. So here's a regular function. Def animal function return lion. Return seal. Return yak. Return bison. Now let's call our function. Lion. Let's call it again. Lion, and again. And again. So the function just returns a string. When we call the function, we always get the first string returned in the function definition. This is because when return is reached, the value after return is returned and execution stops. The rest of the code, this means the other return statements, will be never reached. Okay, how about using a generator? In order to turn a regular function into a generator, we need to use the yield statements. So here's our generator. Def animal generator yield lion. Yield seal. Yield yak. Yield bison. This generator function generates a generator object, which is an iterator. If you want to learn more about iterables and iterators, I have a video devoted to this topic, so feel free to give it a watch. And now let's assign the generator object to a variable. Animal equals animal generator. Now we can iterate over all the 4 elements of the animal iterator using the next function. When we call next for the first time, the generator function will execute until it reaches the first yield statement. Then it will yield a lion and execution will stop. Have a look. Next animal. Okay. When we call the next function on the iterator again, the animal generator will resume where it left off, so after the first yield statement. It will now execute until it reaches the second yield statement. Then it will yield seal and stop again. So next animal, seal. On the next call of the next function on the animal iterator, the generator will resume execution and continue until the third yield statement is reached. Next animal, yak. And let's run next again, bison. Now after yielding bison, it'll stop again. When we call next on the iterator again, the generator function will resume again, but this time there will be no more yield statements, so a stop iteration exception will be returned. So let's call next again, and we get a stop iteration exception. Now that the iterator object is exhausted, it can't be reset. But we can always create a new iterator the same way as before. So animal equals animal generator, and here we have it. In the following example, we define a generator which generates an iterator for the powers of 2. Def powers of 2 exponent min exponent equals 0, while min exponent is less than or equal to exponent yield 2 to the power of min exponent, and min exponent should be incremented by 1. Okay, and now we have pod equals powers of 2 with the argument 8. Now, powers of 2 is the generator function and pod is the generator object. Next, in a for loop, we iterate over the elements in the iterator using the next method. So for I in range 9, print next pod. Now let's run this program, and here's the output: 1, 2, 4, 8, etc. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. For better understanding, let's have a close look at what is going on when the code above is run. So here we're calling the generator for the first time. It returns an iterator, which is the generator object. Now in the for loop, when we first use the iterator in the for loop, which we do by calling the next function, the execution of the generator powers of 2 starts, just like with any other function. Now the code in the body of the generator is executed until it reaches the first yield statement, here inside the while loop. When this happens, the yield statement returns the value of the expression 2 to the power of min exponent, which is 2 to the power of 0, which is 1. Now the execution stops, but the values of any local variables, in this case just a variable min exponent, is saved. When the next method in the for loop is called again, the generator resumes execution at the line directly following the yield statement, so at min exponent equals min exponent plus 1. Then the loop condition is checked, and as min exponent is still less than exponent, which was 8, the loop runs again. And again the yield statement is reached, and this time the value of min exponent is 1. So the yield returns 2 to the power of 1, which is 2, and the execution stops again. This goes on like that until the iterator is exhausted or until the execution of the program is ended in some other way, like by means of a return statement. In our example, the for loop is called 9 times, and this is just the right number for the iterator to exhaust itself. One more iteration of the for loop would cause the stop iteration exception. Generators can also return infinite iterators. In such a case, it's important to make sure there's a way to terminate the execution somewhere in the code. Well, here's our powers of 2 generator. Let's rewrite it so that the generator creates an infinite iterator. So let's get rid of this. And here, let's modify the code like so. While true. And let's call the generator function without an argument. Fine. In this case, it's quite simple because we have the for loop which only runs a limited number of times. So the termination will occur when the for loop is finished. Let's run this program. And we have the same results, 1, 2, 4, 8, up to 256. But if we change the number of the for loop iterations, like for example 20, and we run this program now, we will not get the stop iteration exception because the iterator will not have exhausted itself because it's an infinite iterator. As mentioned before, the condition that must be met for a generator to be a generator at all is that there must be at least one yield statement, but there can be a return statement as well. Using the return statement in a generator causes the generator to return a stop iteration exception. We can raise this exception explicitly in 2 ways. 1. Using raise stop iteration. 2. Using a return statement. Let's have a look. First, using raise stop iteration. Def sum generator yield 1, yield 2, raise stop iteration. Fine. Now 8 equals sum generator. Now next 8, 1, next 8, 2, next 8, stop iteration. Or we can use a return statement. So def sum generator yield 1, yield 2, return. Now 8 equals sum generator next 8, 1, next 8, 2, next 8, stop iteration. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.